In this example, we're asked to determine whether or not this argument, this logical argument here, is a valid argument, and to explain our reasoning. So let's start by just reading the argument. It says, if you do every exercise in the notes, then you will learn discrete mathematics. You learned discrete mathematics. Therefore, you did every exercise in the notes. So let's try to write these out with some logical symbols. So this is the first statement here is a conditional statement, and we can name the first part of this P. P can be you do every exercise in the notes. All right, so you do every exercise in the notes. Q then will be the next one. So we have the connector for the conditional. Then you will learn, or you learn discrete mathematics. So this is Q, and that is you learn this course, right? Discrete math. And at this point, we now can build our little table of our logical argument. The first statement here, so I'll call this Q. Then the other, let's keep going with this, right? So you learn discrete mathematics, so that's Q. So there's Q. And the conclusion to all of this is P. All right, so in terms of our argument, it looks like P implies Q and Q. Therefore, so this is the notation from our notes, therefore P. All right, and the question is this a valid logical argument? So, what do you think? Take a minute to think about it. And it turns out the answer is no, it's not a valid argument. And the reason is because we could find a counterexample, right? So, let's do it. So this is not valid. By the way, so what does this tell us? When we do an argument like this, we assume that these two things are true, and then our conclusion is that the bottom one must be true, right? So if we assume P implies Q is true, and Q is true, then what does that mean? Well, at this point, we can combine these two to say that P implies true. All right, and if P implies true, can we conclude then that P must be true? Actually, no. So let's just keep thinking this out, right? So if P is true, then the statement is true, right? So then the statement is true. But that's not a conclusion, right? That's not a conclusion. So the argument is valid or whatever. The statement is true. So this statement right here is true. All right. So in other words, we get this, right? But that's not the only case, right? Because if P is false, we get false implies true here, and that's still a true statement, right? As far as conditionals go, false implies anything is a true statement. So then P implies Q is still true. And this is the reason that the argument is not valid. It's an invalid argument because we cannot determine that P must be true given the information that we were told, right? So actually that becomes an X. And what we learned then is that this is not a valid argument, and our conclusion that we deduced that P must be true given the information was a false conclusion. It's an invalid conclusion. Okay, so that's how we parse this one.